Welcome back. Now let us come to zeroth law. In fact, thermodynamics is perhaps unique in that it has a zeroth law. Other fields of physics, for example mechanics, it has Newton's laws of motion. We have the first law, we have the second law and the third law of motion. In thermodynamics, we have the zeroth law, the first law and the second law. Historically, it turns out that although the thought process for the second law started with Carnot much before the thought process for the first law commenced, when thermodynamics was formalized using the first law of thermodynamics and the second law of thermodynamics. However, these two laws, it turned out, did not really help us to define the basic concept of temperature. So, physicists came up with a law of physics, a law of thermodynamics, which would help us define and clarify the idea of temperature. At that time it was thought that the idea of temperature is absolutely basic to thermodynamics and hence should get precedence over the first law and the second law. And hence, because it has to precede the first law, it was given the nomenclature zeroth law of thermodynamics. Later on, when we realized that, well, the three laws are not three independent laws, they are sort of linked to each other through the whole framework of thermodynamics, it turns out that for a good study of thermodynamics, the way we are doing, it's good to study the first law first, as we have done, then come to the zeroth law and then go to the second law. So, although the history of the laws or history of the conceptualization of the laws goes as second law, first law and zeroth law, our study will be first law, then zeroth law, then second law. Okay. After this brief discussion of history, let us go back to our idea of an adiabatic wall. An adiabatic wall means a wall which allows work transfer only across it, and hence by implication no heat transfer. This we can say after we define heat transfer as an energy interaction other than work transfer. And a study of the behavior of adiabatic walls led to the first law. Now we define a non-adiabatic wall. A non-adiabatic wall is one that permits or allows heat transfer also along with work transfer. So, Q as well as W is allowed. Q is definitely allowed, depending on the type of wall, W may be allowed or not. Okay. So, this is the definition of what we mean by a non-adiabatic wall. And since we do not want to create too many negative adjectives like non-adiabatic, we call the non-adiabatic wall by its equivalent name a diathermic wall. And now when we study the behavior of two systems separated by a diathermic wall and generalize this, that generalization is known as the zeroth law of thermodynamics. Thank you.